Hi folks, I have decided to come back in and we looked at working out the slope of a sine function, and we defined it as we took a step one side and a step the other side, and that gave us a way of calculating or estimating, a rough estimate of what the value is and a good estimate of what the value is. And I just wanted to very quickly, for people who want to see how we actually do this in the real world, we don't need to do estimates anymore. We know what the answer is, and I'll show you how we might get to the answer. So in this case, suppose I want to know what the slope of sine x is. If I take the value, what we've said we're going to do is we take sine x plus delta, it's kind of what I've got down there, and I subtract out the sine of x minus delta, and my estimate is formed then by dividing this by 2 delta. That is just the estimate of what we've got. Now what we really want to do though is we want to sort of see what happens when delta becomes smaller and smaller and smaller and smaller, and it becomes actually infinitesimal. Will that actually allow us to work out what the slope of this function is? Now, what I'm going to do is, let's just ignore the 2 delta for now. Let's take what we've got on the top. And we learn in trigonometry that the sine of x plus delta is actually the sine of x times the cosine of delta plus the cosine of x multiplied by the sine of delta. Great stuff. All beautifully symmetrical, lovely. Now, then, so that is what I've written there. Then I'm subtracting off this, and so I can basically do that the same. I'm subtracting off the sine of x multiplied by the cosine of minus delta this time, and then let's get it right. I'm still subtracting cosine of x times the sine of minus delta. Now, we know from the shape of the curves that if you take the cosine of minus delta, it gives you exactly the same answer as if you take the cosine of delta. The same is not true of sine. If you take the sine of minus delta, it actually gives you the negative amount. So this goes back to being a plus. So I've just used trigonometric functions that we can prove to show what this top line might look like. Of course, we can actually see sine x cos delta minus sine x cos delta, one thing minus another. These two terms, these cancel out. And here I've got the same thing. I've got cos x sine delta, cos x sine delta. I'm adding 2 of them. So this allows me to say that everything, what I've got on the top line here, is basically just 2 times cos x sine delta. So I can now say, okay, I've got 2 times the cosine of x times the sine of delta, and that is divided by 2 delta. But of course the 2's also cancel. So I end up with something that really looks quite simple. So my function now becomes cosine of x times sine delta divided by delta. Now I want to know what happens when delta gets really, really small. In fact, it gets infinitesimally small. We have a way of writing this in mathematics. It's called the limit, and we just say what happens in the limit when delta tends towards 0 of, need an x in there, the cosine of x multiplied by sine delta over delta. Well, cosine of x has actually got absolutely nothing to do with this limit. And that means that in my equation I can actually take it out. So I can say that is equal to the cosine of x times the limit as delta tends towards 0 of sine delta over delta. So what's that? As things get infinitesimally small. Now, there's a lot of ways that we can work this out that are really quite rigorous. One of the things I might want to do is just replace sine delta with the Taylor-Maclaurin expansion of sine, which is an infinite series. If we do that though, what you find is, although it is a series that is infinitely many terms, when delta becomes 0, infinity minus one of them just becomes 0. They all disappear. So that's quite easy, and that's a kind of more rigorous way. But for now, I'm just going to use Desmos. I'm going to say, well, okay, I'm a mathematician. Before I go into anything too hard, what is the limit as delta goes to 0 of sine delta over delta? Can we tell? And it's a little bit busy now. I haven't got much space. Let me pop that in that hole there. If I put here this alpha now on 0, and in fact, I think, yeah, let's do that. What I've got here in this equation is, in fact, let me use a bit of the board that I haven't really used. Over here, I've got sine of alpha, but I've just set alpha at 0. So that's sine of delta, because it's 0 plus delta. And then we know that this is sine of minus delta, which I told you before, is actually minus sine delta. So this is sine delta minus sine delta. That means sine delta plus sine delta, 2 sine delta, 2's cancelled, so there is sine delta divided by delta, which is what I want to find out as the limit goes to 0. So I can actually model this behaviour by, as I move this down to 0, and you can see that what ends up happening is we get to 1. So this is horribly unrigorous mathematics because we've just used a graph to work out what we think is happening. Nothing wrong with that at all. So I believe that I can now say the limit as delta goes down to 0 of sine delta over delta, which is equal to this equation here, it's saying it is 1. So cosine of x times 1 is equal to cosine of x. I'm coming off the end there. Let me write that here. So here's an example of, we've said, well, how do we calculate the slope of sine? And I'm saying to you here that actually it's the cosine of x. What it means is, and we can do this for virtually any function in mathematics, we just know what the slope is because there's another function in mathematics that tells us what the slope is. It's beautifully symmetrical because the slope of a cosine is actually minus the sine of x. So there's a real symmetry in there. To find out the slope of sine, you use cosine. To find out the slope of cosine, you use sine. Beautiful piece of mathematics. But that's actually the way that we find out the slopes of functions.